The last example I want to look at is cosine. And an example in your packet that is a cosine graph is 10. It kind of puts all the pieces together, but now we're going to be looking at a cosine curve rather than a sine curve. So example 10 is y equals 4 cosine of theta over 2. Theta over 2. Here, don't get freaked out by theta. It's just a Greek letter. It has the same value as x. It's just sometimes we use theta to represent an angle rather than the letter x. So we're going to go through the same motions that we did when we were graphing the sine curve. So I'm actually going to go back over here to y equals, and I'm actually going to erase both of these. I'm going to start by graphing cosine so that we can see that basic cosine graph. Again, its main difference from sine is that where it intercepts the y-axis rather than at a 0 is at the value 1, where its maximum is. And I'm going to type in, but I'm not going to reveal it yet, but the graph of 4, I might actually have to move this to type it in, 4 cosine of x over 2. Okay. So I'm going to click graph in just a minute, but before we get to that, I want to look at the key features to kind of anticipate what this graph is going to look like. So I'm going to look at its amplitude, its frequency, and its period. So this one has an amplitude change and a frequency change. So its amplitude, again, the coefficient of the trig function is 4. That means it's going above the axis by 4 and below the axis by 4. Its frequency change, it has a frequency of 1/2, which means its period, which is 2 pi over the frequency, will be 2 pi over 1/2, which is a complex fraction, which when reduced will give you 4 pi. So its period is now much longer. So I'd expect this graph to be wider or stretched horizontally more than the cosine graph, and I would expect it to be 4 times as tall. So I'm going to click graph on the calculator just to see if that meets my expectations. So it definitely is much taller, and if you notice, it is actually, by the time this original cosine graph completes one cycle, the 4 cosine of 1/2 x is actually only halfway through its period. So it's taking twice as long to complete a period. I have to get all the way to 4 pi before it's done. So what happens when we graph that? So let's do the same procedure that we did with the sine graph, just with this cosine graph. So I'm going to plot it. I'm going to scale the vertical axis. I'm going to go up 1, 2, 3, 4. Because I have an amplitude of 4, I will deviate up by 4. Make that 4 a little bit clearer. 4. And I'm going to go down 1, 2, 3, 4 as well. So I have my vertical and horizontal. I have my vertical scale rather. Now we could work on the horizontal. The horizontal, because I have a period of 4 pi, I'm just going to go over one period essentially. So I'm going to count out, say 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. That'll be the end of the first period. And if I want 2 cycles, I'm going to count out 1, 2, 3, 4, 5, 6, 7, 8 to get my second period in. Okay. Now, when graphing it, again, we're going to have to pass through the 4 quadrants or the 4 phases of the graph. So I'm going to break each period into 4 parts by dividing it in half, and then each half in half will give me 4 equal parts. So since I went 8 boxes, each quarter is 2 boxes. So I have a scale of every 2. And then I'm going to transcribe the cosine graph. So again, the main difference between sine and cosine is basically its beginning value. So cosine starts at its maximum. So this graph will start at 4, and then it will pass through this kind of that same pattern that the sine graph did. So I'm going to go down to the axis as the first key point. My next key point is down to the minimum. So my next key point is down to the min. My next key point is back through the axis, and then I return at the end of its period to its starting value, and that will give me my first cycle of the cosine graph. Just like with sine, it then repeats its values every period. So when I went 4 pi over, I have the same value. So then I'm going to have to follow that patterning all the way around the graph, kind of as I go, and up. And I should have that exact same cycle repeat. Okay. Now, the last thing I'd want to mention about this is what happens if a negative gets involved. So I'm actually just going to make an example, And I'm going to say, well, what happens if I have the equation y equals, let's say, negative cosine of x? What would happen to that cosine function? Well, you may remember back when we did function transformations that when we multiply by a negative, the graph basically reflects. So what this negative is going to do here is it's going to reflect the original cosine function. And in particular, it's going to reflect it vertically. Okay, so if I imagine what the cosine function looks like, so I have it right here. If I reflect this vertically, it's just what once was positive will now be negative. The reflection of 0 would just be itself, or what was negative will now be positive. 0 is itself here. So I'd expect this graph to just be a flipped over vertical version of cosine. So the negative cosine graph should be the exact same thing as cosine, except reflected. So I'll be starting at negative 1 and 1. Oops. Between negative 1 and 1, just like the original cosine graph. The original cosine graph has a period of 2 pi. It has 4 parts that it needs to pass through across that period. And since cosine started up here at its maximum, negative cosine will start at its minimum and just be the reflection of that exact same graph. So it's the same graph flipped over, essentially. The exact same thing happens if you were talking about negative sine. So it's the same as the sine function, same amplitude, same frequency. The only difference is that it will start at 0, but rather than rising in the positive direction, if I'm reflecting it, that will flip downwards. So when I'm graphing sine, by the time it gets to the end of its period, it will have done so flipped, so it's reflected vertically. So when you see negatives on your trig, in front of your trig functions, a negative on that amplitude, everything is the same, but the points occur in a reversed direction vertically. So keep that in mind when you're working through examples that involve negatives.